Let us look at proposition number 3 of book 12 of Euclid's Elements. The proposition says any pyramid with a triangular base is divided into two pyramids equal and similar to one another, similar to the whole, and having triangular bases, and into two equal prisms, and the two prisms are greater than half of the whole pyramid. There are three parts to this proposition. First part is to actually divide this into two prisms and two pyramids. Okay, and then prove that those two pyramids are equal and similar to each other, and they are similar to the whole pyramid. Then we have to prove that the two prisms are equal to each other. And then we have to prove that the two prisms are greater than half of the pyramid, overall pyramid. So let's take it step by step. Given a pyramid with triangular base ABC and vertex D, bisect AB, BC, CA, AD, DB, DC. So let's do that. Now we join these points. So HE, EG, GH, HK, KL, LH, KF, and FG. Immediately, I'm sure you can figure out the two pyramids and the two prisms. Do you notice here there is a pyramid? There is a pyramid here. And can you see a prism with parallelogram as a base and a prism with a triangle as a base? So let me make, color it so that it, becomes very clear. So this is your first pyramid. This is your second pyramid. Then we have this prism. Can you see that now? That is one of the prisms. And the second prism is in front. So as far as constructing this is concerned, it's pretty straightforward, isn't it? But the thing is to prove that these two pyramids are equal and similar to each other and similar to the overall pyramid. And then that these two prisms are equal to each other, and then the prisms are greater than half of the overall pyramid. So let's proceed. Basically, when you have to prove that these two pyramids are equal to each other, what do? Basically, you have to prove that the different faces or the corresponding faces of these pyramids are congruent to each other, because each of the face is a triangle. So you have to prove that these triangles are congruent to each other. Let's see. Triangle ADB. In triangle ADB, AE is equal to B because E is the midpoint. AH is equal to BH because H is the midpoint. So H and E are the midpoints of AD and AB. That means what? That EH is parallel to DB. Again, in triangle ADB, AH is equal to DH, DK is equal to KB. That means HK is parallel to AB. So what have we proved? EH is parallel to DB, or in our case we can say KB. Similarly, we can say HK is parallel to EB. So that means the figure HEBK is a parallelogram, which implies that HK is equal to BE. Now, since BE is equal to AE, BE is equal to AE, implies AE is equal to HK, because HK is equal to BE and BE is half of AB. That means AE is the other half, other equal half. That means AE is equal to HK. Since AH is equal to BH and AE is equal to KH, and angle EAH is equal to KHD. Now, how are these two angles equal? Because AE is parallel to HK, and we can say AH is the traversal. That means exterior angle is equal to the interior opposite angle. So these two angles are equal. That means triangle EAH is congruent to KHD, which means EH is equal to KD. Now, similarly, we can show that triangle AHG is congruent to triangle HLD, which implies that HG is equal to DL. Here, EH and HG, EH and HG are meeting each other at H. Similarly, KD and DL are meeting at D, and they are not in the same plane, and they are parallel to each other. So, which means angle EHG is equal to KDL. Now, EH is equal to KD. HG is equal to DL. And angle EHG is equal to KDL. That means triangle EHG is congruent to KDL, which implies EG is equal to KL. Similarly, we can show that triangle AEG is congruent to HKL. So, which means we have shown that all the four faces of these two pyramids, corresponding faces, are congruent to each other. So that means pyramid AEGH is equal to pyramid HKLD. And their bases are triangle AEG and HKL, that are triangular. Now HK is parallel to AB, implies HAE is equal to BHK. These two angles are equal. Angle DBA is equal to BKH, and HDK is equal to ADB. So that means triangle ADB is similar to BHK. Similarly, we can show that triangle DBC is similar to BKL, and triangle ADC is similar to BLH. Okay? And BA and AC, where is AC? AC are meeting at A, and they are parallel to KH and HL, meeting at H, not in the same plane. That means angle BAC is equal to KHL, and we know AB is to AC is equal to KH is to HL. So that means triangle ABC is similar to HKL. So that means pyramid ABCD is similar to pyramid HKLD. But we already saw that these two pyramids, AEGH, is equal to HKLD. So that means, since we have already shown this, it means that pyramid ABCD is also similar to pyramid AEGH. So we have shown that these two pyramids are equal to each other and they are similar to the overall pyramid. Now we have to show that these two prisms are equal to each other and they occupy more than half of the overall pyramid. Now, BF is equal to FC, which implies that parallelogram EBFG is equal to 2 times triangle GFC. How? Because they are on the same base. This parallelogram and this triangle are on the same base and they have the same height. And we know in such a case, triangle will be half of the parallelogram. So, prism contained by triangles BKF and EHG, the green one, is equal to the prism contained by triangles GFC and HKL. Now, we have to prove that these two prisms are more than half of the overall pyramid. So for that, let's join EF and EK. EF and EK. Immediately you notice that actually we end up with a pyramid once more, which is going to be equal to this. So these two pyramids are equal to each other. That means all these three pyramids are equal to each other. Prism contained by BKF and EHG is greater than the pyramid EBFK because this pyramid is contained inside the prism. Pyramid EBFK is equal to pyramid AEGH is equal to pyramid HKLD. So all these three pyramids are equal to each other. Since this prism contained by the triangle BFK and EGH is greater than one of these pyramids, that means it is greater than these two pyramids. Both these two prisms are equal to each other. That means both these prisms are greater than these two pyramids. And since there are only 4 parts to this pyramid, that is 2 pyramids and 2 prisms, that means these two prisms occupy more than half of the overall pyramid. So prism contained by BKF, EHG plus prism contained by GFC and HKL is greater than pyramid AEGH plus pyramid HKLD. That means it is greater than half of pyramid ABCD. That was proposition number 3 of book 12 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.